So first question in this rectangle, if you use the picture, you notice that we're talking about D to E and E to B. Those two pieces are equal to each other, so you need to say 2x plus 9 is equal to 3x minus 2. Move the smaller x, so subtract the 2x to get x. I still got a minus 2. I still got an equals 9. I add 2 to get 11 for x. But note the question does not ask you for x. It says find A to C. And A to C is the whole way across. Well, plugging in 11 into either spot, 2 times 11 plus 9 will tell you that each piece is 31. Remember, they're asking for the whole A to C, which would be 31 and 31. So nice job on 62. This one has some good traps. But like I said, be sure to answer the correct question, as always is the case in these geometry problems. It's not about the algebra. Nice job if you were able to get 11. Now you got to be able to plug it in. Find the measure of angle GEF, which is this angle here. Look at these two angles. They're not necessarily equal to each other. You can tell by looking they're not equal to each other. What you do know is that in a rectangle, they add up to what? They add up to 90. Combine your x's to get 11x. Negative 6 and 8 is 2. I'm going to subtract 2 to get 88. And divide off the 11, and x is 8. But remember, we're not necessarily looking for x. I'm going to plug in here because I'm looking for this angle. So 2 times 8 plus 8, which would be 24. And that is a smaller angle. So 66 probably wouldn't have been an option there. Unless it said drawing, not the scale. We're just given an angle, nothing to, no algebra didn't necessarily work. Just understanding that angle ABE right here is 20 degrees. So if this is indeed a rectangle, that's got to be 70, and there's a bunch of 70s and 20s all around this rectangle. We're asked for angle EDA, which is this one up here, and it looks like 7. Oh, I did my 20 and my 70 backwards, and I could tell because this is clearly the bigger angle. So backing that up or changing colors to correct that. Alternate here, remember 70 would go over here and 20 would go over here. So the angle we want is definitely 70. So like I was saying, teaching geometry, you can kind of self-correct a lot of times by making sure you're looking at the picture. This is a preview of some triangle stuff we got to do later in this unit. Not difficult. G to F is 4. I was asking you as a preview question, do you know how long G to C would be? And you can tell G to C is a little bit longer. It's either twice as long or 3 times as long, but it's still not quite 3 times as long. The answer was 8. And again, this is just a preview of something for next week. So you already kind of figured it out. Good for you. If not, again, we'll talk about next week. So one of the best styles of questions in this unit is questions about when you double and triple your radius. And apologies, I should have included the formula, though warm-ups are open notes. In a sphere, the formula is 4/3 pi r to the third. You'll get this question right if you understand this pretty simple question. What's the first thing that's happening to radius in here? Radius is being raised to the third power first. PEMDAS, exponents will come before anything other than parentheses, and there's no parentheses. So when I double my radius is third powered, essentially changing that 2 to a what? 2 to the third power is an 8. So we're really multiplying by 8s. All because that's a third power that's hitting my double or my times 2. You're welcome to do a couple dummy plugins on Desmos. Pick a radius of like 1 and then double it to 2 and see what happens. If we multiply, the volume would be 8 times bigger. Getting another one of these, making sure you're good. A cylinder has a volume of 64 pi. The radius is 4. What's the height? Remember, capital BH, and the capital B is a circle. So plug in what you know. 64 pi is the volume. The radius is 4. And what is the height? Good news. You can get rid of all this stuff at one time. What's all this stuff doing with h? It's all multiplying with h. How do you get rid of times? You divide, and what you do to one side, you go do to the other. The pi's are going to cancel, and you're basically looking at 64 divided by 16, aka 4 squared, which is 4. Height is 4. I always go back and double check and make sure I'm answering the right question, which I did right quick. I think we saw this earlier. I shouldn't have scrambled it. When I worked this out earlier, what did I do with those two angles? You add them together, set them equal to 90 because they make a 90-degree angle. Very important one from yesterday. What do you do with these two? Do these add up to 90? Nope. Are they equal to each other? You got an acute here and an obtuse here, so no, they're not equal to each other. Those are the consecutive angles, and they always do what? They add up to 180. So 4x plus 8 plus 6x plus 12 is equal to 180. Simplifying, that's 10x plus 20 equals 180. I'm going to subtract 20 and divide by 10, and I'm going to get x is 16. I was nice here. I didn't put 16 as an answer choice, but good work if you got this far. All you need to do from here is plug in. And since I'm looking for angle C, I'm going to plug in over there in angle A because A and C are the same in a parallelogram. 4 times 16 plus 8 will get me my answer, 72, I believe. Note that's definitely an obtuse angle in the picture. But what I said in the question that's underlined over here, drawing may not be to scale. So that's me just covering myself, knowing that my picture didn't match. But that's typical test writing behavior for any like testing site, or I would think a accurate test like the ACT would probably not be off like that. They may still say drawing not to scale, but they would make it definitely look like the picture. Find the measure of angle WZY. Looking at WZY, it's over here. Easy one. What do you know about 105 in this one? They got to add up to 180. So angle Z is easily 75. They're consecutive angles. They got to add up to 180. And you see this acute. Take a cylinder and cross-section it perpendicular to the bases. These should be easy questions. Make sure you know your shapes and the difference between a parallel slice and a perpendicular slice. Parallel would be this way, parallel to the bases. It would be a circle, but that ain't the question. Perpendicular would be straight up and down through the shape. And that would be flat on top, flat on the bottom, flat in the front, flat in the back. Definitely a rectangle. Potentially a square, but square wasn't an answer choice. Again, what's true about A and D? We worked this earlier. They total 180 degrees. Again, I definitely should not have scrambled this one. And finally, if AC is 10, that means this is 10, so all the pieces are 5s if it's a rectangle, and it is. So how long is D to E? D to E, again, like all of these would be 5.